Hey everybody, Mr. Regan here. And up to this point, you have created an experiment and you have looked at the variables that we're going to be using within that experiment to figure out what's going on with our space pod. Your plan to test the investigating question that we see here below will need to have us find measurable data in order for us to draw conclusions about it. So we need to figure out how we're going to find this measurable data if the same strength force is exerted on two objects and we're looking for how that might affect them differently. Your experiment will need to measure and calculate the velocity change that occurs as we apply the same strength force to our different objects. So let's take a look at how we're going to calculate and measure that. So in each of our tests, each of your objects is going to start at rest. Its initial velocity is 0. This means that the object change in velocity will be whatever the final velocity that we calculate is after we exert the force. So we're trying to calculate what its final velocity is. And we're going to look at how we collect and calculate that. So velocity is the speed in a particular direction. So we need to calculate speed of our different balls, whether it's the golf ball or ping pong ball, and indicate the direction to measure and calculate its velocity. So let's go ahead and look at some practice questions on how we calculate its speed and find its velocity. So we have three random objects that are moving a specific distance in a specific amount of time in a specific direction, and we're going to calculate its velocity. So speed is distance divided by time. We take the distance the object travels and we divide it by the time it takes to get there. So if we have an object moving 10 miles in 5 days, we would do 10 divided by 5, which gives us 2. Now we look at the distance, which is miles per, and we look at the time, day. And then in order to figure out the velocity, we have to take the speed plus the direction. So what we just calculated was the speed, distance divided by time, so 2 miles per day. Then we add the direction, which would be north. So 2 miles per day north. So if this is somebody's car, maybe they're traveling 2 miles per day north. The next one, 100 feet is the distance an object traveled. Did that in 25 minutes, and it did that in the direction left. So we look at our equation here, speed equals distance divided by time. So we would take 100 divided by 25, and we would get 4. We know it's distance divided by time, so it's feet per minute. And the direction it's traveling is left. So maybe this is a very small bug, and it's traveling 100 feet every 25 minutes. So it's traveling 4 feet every minute, and it's maybe moving in the direction left. Last one, 1,000 centimeters. An object's traveling this distance in 100 seconds, and it's moving up. So we would do 1,000 centimeters divided by 100, which would give us 10. We know it's moving centimeters per second, and it's moving up. So this could be maybe a small toy rocket moving 10 centimeters per second up. So notice we first had to figure out how far the object traveled. We then had to figure out how long it took. We would divide that distance divided by time, and we would add the direction it's going, north. And we would create this table to show those calculations. So your job is going to take this idea of how we measure velocity and create your own table for how you're going to collect the velocity of your two different balls, the golf ball and the ping pong ball. You're given a table, and your job is to figure out what to put in the columns and in the rows as your headers, and then where you're going to be collecting your data. If you need to add rows and columns, you're more than welcome to. But thinking about not only how we calculate velocity, your job is to think about how can I set up a table to collect data on the velocity of our golf ball and the velocity of our ping pong ball. If you have questions on how to set up your table, reach out. Otherwise, good luck.